So we're going to do a talk on Go here. And the goal with this talk is to walk you through a little bit of the Go programming language. And our mission tonight is to make a web app. But when you learn a programming language, you often get exposed to the set of libraries that the community builds, right? And you can bolt in all sorts of things from open source projects, which is awesome. It's a great way to go. But we're going to give ourselves a constraint tonight of using only what's available from the Go standard library. So the standard library includes a set of packages that they think are important and relevant, and we're going to see how far we can get with them to make a web application that does some stuff. Most of this will be a very toy application. Don't expect, the next Instagram or something coming out of here in an hour. But my hope is that showing you the concepts of what's available, you'll be able to extrapolate and say like, okay, now I know about this concept, and maybe I don't want to use this. The standard library seems pretty limited in this regard, whatever that regard is. And then you can know where to explore, or just get a mental model for how web apps are built with these kind of systems. Because the things and the terms that I'm going to use tonight are pretty standard terms that you're going to hear in a lot of different frameworks or libraries that do things on the web. So this is our goal. Normally I would be brave enough to type out something, but there's a lot more code here tonight, so I have some different branches in my Git repository, and we'll kind of jump ahead and we'll do little code explainers. We will run the code at each step, but you won't be catching me typing this evening as much as I can avoid it, just because it's slow and who cares about that stuff. Okay, so let's get going. Let's see how far we can go. We can get pretty far. There is some limitations that we're going to see that, well, maybe I'll just leave that as a surprise. There's some limitations. So we're going to start with the beginning. You need a web server, and that server's job is to handle HTTP requests and basically respond back. Somebody's coming to your website, this is the thing that's going to do that. And so what does this look like with a Go service? So here we've got our entry point. I put very little here. I actually put the print line just so that we can see some kind of output, because if you start this up and you don't have that, you literally see nothing. It's just like, is this thing on? Tap the mic kind of scenario. But with Go, you have to start with a couple of things that have nothing to do with web development, just our general Go things. You have to start with a main package. So that's what's at the top. So package main, and then we need a function main that's the entry point. So from those two pieces of information, Go will know, like, okay, this is where I got to start. So we're going to run this function, and then it's going to do its thing. In this scenario, we've got two separate things. So the first thing that you see, that router, is going to be our next step, but you needed something to start with. So I guess I could have put nil there, but I left something. Importantly, though, we've got an HTTP server, which we're getting from the net HTTP package, and we're making it run on port 8000, and then we're just saying listen and serve. So it's going to handle just HTTP requests. If you dig into the documentation, like if you want to go crazy with the standard library and really dig into it, you can do this securely. So if you want to go through the process of getting TLS certificates and doing secure communication straight from the Go standard library, that's possible. You put in certain creds that go in there and point to different file paths, and you can make it all work. I'm not going to cover that. I thought about, should I do dev certs and do that? No, it wasn't worth it. So we're just going to do plain Jane HTTP, which should express all the concepts. And then we have a router, which is going to be the thing that different, like you think about a URL, you've got these path elements, the slash this, slash that, and those are routes, typically, is the name used. And so the Go standard library likes to call it a MUX. If you're a hardware person, like maybe you know what a multiplexer is, like that, like this kind of bothers me. It's not really a multiplexer. I have a hardware, like an electronics background. It's like, ugh, you're kind of, okay, I guess software kind of abuses terms sometimes. So I don't like to think of it as a MUX. A router feels like a much more natural name for me. So we're gonna call it router. You can call it MUX, you're not gonna hurt my feelings. If you go back and be like, he's dumb. So that's where we're going to begin from. So to run this code, we'll go over to our terminal. This is also really small. Sorry. Let's get that going. and let's clear the screen. Oh, it's lagging, no. Boo. All right, I'm gonna do my best to just run this and then let it catch up. We can do a Go build. Go as a programming language gives you a whole tool chain that you can work with. And if you have zero context about Go works from here's our source code files, and it does have it has a compilation step that builds a binary, and that's the thing that you're going to actually use and run. I'm going to bring up an example later that actually uses it. But as like a developer mode where you just want to, you don't care about having the files around, you don't want to mess with that stuff, you can do go run and then give it the code the entry point you want to start from, and just kind of compiles it, runs it in memory, figures it out, and it doesn't leave anything behind. So we've got our server running here, and if we go to, hopefully everything is working just fine, if we go to localhost on port 8000, we're going to get a 404. Andrew, would you mind getting that? So we have a router. It doesn't do anything. We've not told it to handle anything. So we're effectively at the root, some slash of the web server, and it just says, I don't know, I got nothing. But we do have, what you would not get is, if I had stopped this server, it would say, I can't connect to this. So this does at least give us some indication that that the server is running, and it's reporting back a status of nope, nothing to see here. So that's the basis for where we begin. Let me pause between these. I think there's a good opportunity. Does anybody have any questions about the server so far? Yes, Chip.
What version of Go do we need for this? Because it's standard library, right?
Yes, good point. Some of the features I'm going to show tonight are from much more recent versions of Go. I think even, what's the latest, 123? I don't know. But the server has been in there for time immemorial, as far as I know.
Okay, cool.
So you should be able to do this on any version of Go you can manage to find. And I've got, actually, let's see. I have a Go has a module file that you have to set up to say, you have to specify which version of Go you're going to work. So I guess we're running, to answer your question of what is this running, it's running 1.22.6. Okay, so we've got our server going, we've seen it run. Let's go back to our app file and let's bring it up to the next step. So we're going to go to the router. Boom, new chunk of code. The new section here is this. You can't see that quickly. Where now we're introducing the concept of routing. We don't want 404s for every page view we have. We actually want our server to do something, and this is where you build your application to do whatever your application is supposed to do. I chose a really silly scenario here of just reporting, saying hello. It's almost like an echo server to that level, but a little bit more as it has hello on it. And I want to highlight a couple things about this. One of the aspects of routing, and this is maybe, Chip, to your point about what's new and needed in later versions of Go, is a very recent version of Go. It might have even been 122. Added some more advanced features for the path stuff. Previously, the router would accept /users, but if you wanted to do dynamic values and that sort of stuff, it really just wasn't there. So which greatly limited the utility of this, because having dynamic elements in a path is something that happens all the time in web apps. So this is much needed functionality. But the way this is working is we're saying the router's getting has this handle func call. And so what it's going to do is it's going to take that path that you see, that string, and it's going to be able to respond to that. And effectively, we've done an inline function. If you're going to design a better app, you might actually have a function name here. But I just did an anonymous function. And all the functions that respond to this handle func have this interface. They're going to expect some kind of writer and some kind of request. The writer is what you write data out to. If you send that data onto that writer, like we're doing in the body there, the print line, we're saying take hello, take the value from the user, I'll get to that in a second, and send it back out. And so what we'll see, actually let's do it now, better to show than tell, right? So if we run the app again, and we jump over to users, let's say Andrew, we see, very small, thinks it's Danish. I saw this last time, I had no idea why. We see, hello Andrew. Okay, so the layer that I added on that was maybe not as obvious is there's actually, it's coming, I promise. There's actually like a security vulnerability with that verse. If we've just taken this version, then this is where this piece right here, the user and this request path value, those are the connection there. So we've got Andrew here, but it's possible, I don't remember the exact kind of string you would need to use, but it's possible to like inject in something there and make it come back and basically do something bad in the response to the browser. So we still have to think about security when we're doing web development, and this is one of the tools that would make that string safe. So basically you're saying, I don't trust this user's input because it's something that can be changed and modified. And here we're going to escape that sequence of characters, so it's going to be safe for presentation on the web. So that's another feature that's kind of baked into this routing discussion that we have here. So that's the basic element with routing. There's another layer here though that routers can be like nested. You can think of having sections of routing. And that's what I'm showing off with this like V2 component. So imagine, we haven't made this smart and talked about JSON yet, but imagine you've got some data that you care about and you want to actually send it out. And you've started with your first version of your API and you want to return some information about Andrew or Chip or Matt or whoever. And you've got your data coming back. And now you're ready to like, oh shoot, my front-end client that is using this API needed some fields, they wanted to remove some fields, and we need a version 2 of this thing for reasons. So what we can do with the routing capability is take another router, or another MUX, and call it V2 here, and we can put a route inside of that is like the path that we care about. And then what we're doing is then we take that V2 MUX and we're wiring up to this handle function. The difference between handle func and handle is that if we bring up the documentation here, handle func expects that function, like a function to call, which makes sense, right? It's called handle func. If we go to instead look at handle, what it is going to expect is some kind of handler. Now the details of what handler happens to do, not super important if you're calling the MUX thing directly, just take it for granted that it does the right thing. If you want to implement your own, I would send you to the Go documentation. And I think it's a method called serve HTTP, but don't quote me on the specifics. But we know that the MUX, the V2 MUX, implements that handle interface. And so we can plug it in, and then it wires that together. Now, there's one important element here that's going to make this work. That maybe some of the other third-party libraries that do routing, there's a bunch of them out there, would do for you that is not so nice in my opinion. Notice that we had to do this strip prefix thing. What's going to happen is if you don't incorporate that, the path that's going to be sent to the V2 MUX is going to be that full /v2/users path, okay? And so it's not going to match, and it wouldn't find it. So by taking this /v2 strip prefix, we're essentially taking off that first portion of the path, and we give this nested router a fighting chance to actually find the real thing that matters. So if we follow through on this, we should be able to go to V2, assuming everything's hunky-dory, and see the version 2 of this. So you can see how you can start to get more complexity in your routing by doing this kind of thing. All right. Let me pause there. Any questions?
Yeah, I got one.
But I feel like the question isn't related necessarily to Go, but rather just like a lack of understanding and some basic fundamental concepts. So could you explain the HTTP response writer, like what that does again? I'm not sure.
Okay, sure. So the writer's job is to write bytes back out to the network. At the most base level, that's what it's kind of doing. The fact that it's a response writer means that it knows it's in kind of an HTTP context. Have you studied HTTP at all? Have you looked at it? Okay. So you're aware that an HTTP response has a section of headers?
Yeah.
And then it has like a body, right?
Mm-hmm.
So when you do a write on that thing, essentially you're writing bytes that are going to go into that body of that HTTP response. There are other methods that come with the response writer that allow you to add to the grouping of headers. And there are other attributes that you can modify from the writer. So your objective as a handler function is take the request, whatever data it gives you, path values, or you can, some of the requests can have bodies in them if they're post requests. There's all sorts of data that can come in, and then you do like a transformation of whatever you decide, whatever your application's meant to do, and then you write that data out.
So is this essentially returning
That's exactly
a
right.
standard HTTP response
Yes.
back to the person who sent you the initial?
Yep, totally. And we can see that. We can actually, so if we come over to the developer tools, I'm in Firefox here today, but Chrome has them too. You can go to View, Developer Tools. We can go to our Network tab, and I can refresh this page, and we'll see it's trying to get a favicon, which our little server is not doing. That's annoying, but so there's got a 404 here. But here is our actual HTTP request information, and we can go over to the response and see there was a response payload. Now, Firefox is choosing not to show the whole payload, the whole response, but or at least show it in one go. Like they're kind of they're splitting it up into here's the header section of this is what came back from the server as response headers, but there's also the body. So they're just presenting it differently. But yes, all the bytes did go over the browser.
If I have a standard website that's written in PHP or something, and it's hosted on an Apache server, it will produce an HTTP response.
That's correct.
When I make a request of it. This is the same HTTP response if I, manage to do a PHP site that produce the same kind of output back to the user's browser.
Correct. Yeah, that's exactly the scenarios. Like, so every language, well, okay, not every language, but you know what I mean. Many languages have web support of some kind. Python, PHP, Perl, Ruby, Go, Java, the list goes on and on, have their own versions of web servers, and the jobs of the web server categorically is like, requests are coming in, I gotta respond. Like,
so
that's conceptual.
You're running Go on this server, and it's published an address.
Yes.
So requests that come into it are handled by Go, and it produces a standard, we'll call it a standard, response.
Yep.
So, somewhere in the headers, it may or may not say, this is Go. I can't remember all the details.
I think this one does not advertise. Some servers do advertise and say
powered by whatever it is.
right. I've never been a fan of that, frankly, because it's like a secure. Like, why don't you just broadcast to everybody what you're running? It doesn't seem like a good idea.
Yeah, you don't want to tell the world what you're doing.
Yeah.
So they will have a better clue as to how to get in and screw it up.
Yeah, the InfoSec guy over here, he's like, yeah, that's a good idea.
Come on, man, easier.
So yes, and then in this case, the address. So what I'm doing is I'm running this Go process. I'm using this Go run app, which is running our thing, and then it's starting up a server that's listening on this particular port 8000, and it's the place it's listening for is just on the local network right now, which is why I'm doing localhost colon
That's
8000.
great.
Okay, so we've got routing, but we've got a lot more cool stuff that Go can do. And I keep forgetting to show the little thing. So this is not the kind of router we're talking about. It's not the one that you have in your house that you probably want to smash with a hammer sometimes. Yeah, different kind of router. All right. So next, let's talk about JSON or JSON. Depends on. Yes, sir.
Can I take pictures?
Yeah, go for it.
It's too good. Right?
Go for it. So Go can do JSON. And we'll see an example of what this looks like. Let's get our next version. So I'm going to stop the app. Let's go to our next branch and check out what's changed. Now, I tried to group this just linearly because it's going to be easiest. There is one change above that we'll have to get out of here. So actually, let's start from that thing. So the first thing I did is if you want to represent like a data model, something you care about. I picked a movie because it's just like everybody can understand what a movie is, I hope. And I didn't want to get super creative on this. So we've got a movie and it's got two fields in it. It's got a title and it's got a release year. And you can think about, actually we'll see this later, you can store data in some other source. In this particular example, we're just putting like a raw set of data here. So we've got an array of movies. That's what this syntax says. And then we've got two movies listed here, two of my favorites, Shawshank Redemption and The Usual Suspects. And I've wired up their attributes to show like this is the title, this is the release year. Pretty good set of years right there, mid-90s, check it out. And so so what we're gonna do is we're gonna take this JSON encoder, and this comes from the encoding/JSON package that's available from the standard library. And the JSON encoder's job is to take the internal Go representation of the data and then turn it into that JSON format that many of you have probably seen with the curly braces and double quotes and stuff and numbers and booleans and all that jazz. So we build an encoder which kind of wraps around the writer, and then we tell it what we want to encode. Like encode, decode. I struggled with that for a long time, but encoding is turning it into code, which is like you can think of bytes as like code. So I always mess up like which direction was it? What was it? Decode? Yes.
No.
Oh, okay. So we are taking our data that is in memory and we are encoding it. We're sending up a network that way. So this one's pretty straightforward, but it's super powerful. So if you want to make like APIs that little mobile applications can use, or web apps, or all sorts of stuff, this is where you start. You want to be able to encode your JSON. So let's run this one. And I also introduced one more thing on here. I didn't talk about the routing, but notice that this time, I'm too short to be able to reach that. So let's do this, move this up. Okay, now I can reach. Notice that we included an HTTP verb here of get. And previously, no verb. So the inclusion of that verb, which is like, if you know the HTTP verb, they're like get, post, put, patch, delete, these sort of things, will cause the router, the MUX, to behave differently. If you don't include it, then that path, like what we have with the users thing, will respond to all HTTP requests. It'll be able to receive them all. Now it's going to not behave any differently because we didn't code anything in there, but it's ready to answer any of them, and it's going to do the same kind of response there. By including the get, we have said that this route will only respond to get. If you try to do a post, it's going to say, probably say 405 method not allowed. Probably. It's 405, right?
I've been a while.
Okay. Anyway, so that's what the get is on there for. So if we jump over to the browser and we go to /movies, then we see the browser shows the data in JSON format. Now, importantly here, notice the lowercase t, lowercase r. Y'all see that on the title release here? Okay, go over to the Go code, and wait a minute, we've got capital T, capital R. Now, the reason that these are capitalized is a Go visibility thing. So you can imagine this, like maybe this movie, maybe you are, the word that is often used with this is like data modeling. You have a model, some kind of representation, a model that you want in the universe. So if you didn't want it all in a big gigantic file, you might create a directory in your Go application called model, and then you'd have a package model. But to be able to use movie in a different package, it has to be visible. It has to be publicly available. So Go has this notion of privacy, what is private data and what is public data. And it does that with the capital letter versus a lowercase letter. It was actually kind of it's the first time I've seen this done in a language, and it threw me at first. Like it felt pretty strange, but it's actually pretty elegant as I've come to appreciate it for what it is after a couple of years of doing Go. But that leaves this problem that remained is if we had just encoded this data and it had these capital elements, what you would have seen in the JSON output would literally be capital T title and capital R release year. So what we're able to do is we've got these like tags at the end, which is extra kind of metadata that you're able to add to the struct here to say, hey encoder, when you see one of these structs, this is how you should treat that field. Okay, and your JavaScript teammates are going to be much happier with you if you do this.
Is that a string with the backticks?
It is a string, and I think there's something. I think it's don't quote me on this. I think it's like a literal. Like if you use the backticks, it will not do interpolation.
Okay.
But it does and stuff inside it, I think. Allows you that kind of stuff.
Yeah. So.
But I can see clearly you're using double quotes.
Right. It also gives you a different delimiter.
Sure.
Yeah. That
But
lets
I understand it might do other things that regular string is different. Okay.
Yeah. So it's like I think it's the intent is treat this as a constant value. But again, somebody go read the Go spec and don't trust me on everything I say. I'm somewhat knowledgeable, but by no means an expert in Go. Okay, so we've got some JSON encoding. Anybody have questions about that section?
I have some questions.
Yeah.
Random stuff. Let's go look down at where you're in do the encoding. So is there a risk of, I've seen this in Python, I think you can see this in Go, and we can get into like the internals of Go, like io.writer and stuff, but I didn't want to get into that too much, but is there, sometimes with writers, things are buffered, right? And so I'm curious if there's a risk of like, oh, this function ends before maybe all of the movie data has been written and put out to that writer, or is that one encode line just everything goes and then it's done? You know, is there like a risk for that kind of thing?
Yeah, I honestly don't know off the top of my head, but I do see how that can be a challenge. Like if there's the notion of like streaming, like if there's some kind of stream that you'd be reading from, or if there's an iterator aspect of this, that I don't know. Actually, I feel like there's a new, like the latest, not even released yet version of Go, or just came out, a new iterator protocol in Go, and I don't think that people are. There's some like contention of like, is this good or bad? Okay. So as far as I know, there's not like a well-defined iterator protocol for handling streams, but again, that's might be beyond my pay grade at this point, sort of detail.
Okay. I have another question.
Go for it.
I know if other people have questions, I don't want to like give you a question, only question for some. So you add the HTTP verb there, 3 lines up from 36.
Yeah.
What if you wanted to have a route called get, all caps get? Could you do it? How would you do it?
Well, I think the key would be it would have to start with slash.
Oh, okay.
So if you wanted
slash is how it made me know.
Right, if you wanted a route called capital get for some reason,
yeah,
that'd be the weirdest API I've ever seen.
Yeah,
maybe, but I'd have questions with you as a designer, perhaps. But yeah, I think you would do I think you would just do /get,
Okay.
and then it would do that, and
And then
it
just
responds
the
to all the
slash-
verbs.
Okay.
Like if you're doing a delete to /get, I'm like, what's wrong with you?
Post/get.
Post/get, yeah. Okay.
I have a quick question.
Yes.
Before we move on. So just this is a semantics question, like syntax thing. So do functions essentially just return like the last statement?
Mm.
Oh,
in
That returns void.
This,
I'm
okay.
talking about like the encoder.
I am maybe ignoring, like this one, some of these might be, so this one returns an error.
Okay.
I'm ignoring my errors, don't do that.
Makes sense.
But yeah, so Go doesn't, I think if I had a linter, it probably would have yelled at me, being like, dummy, you had an error, you had the possibility for an error and you didn't check it. What are you doing? So that's one aspect. I do think that for the actual function signature that like handle func wants, it does not have any sort of error in return. I've actually seen that be a criticism of Go's like design here, because it's like, why would you not return the possibility that your handler might have an error? Like, what are you supposed to do instead? Like, there's a bunch of weird hoops I think that people jump through in order to record errors for the fact that the actual like handle func just didn't make it into the signature. And Go's like has a super strong stance on they do not want to break backwards compatibility, so we'll probably never see an error on that function, which is a real shame. I mean, maybe they'll make a handle func error thing where they'll add a new API that people will adopt or something like that. But
So the actual network output is achieved with that W variable. That's your writer, so
Yes.
you're handing the writer to the encoder, and then when the encoder encodes, it pushes it to the writer's output stream.
kind of wrapping up. Yeah.
Okay.
And I will comment, one of my distastes for Go is they really love short variable names.
Yes. Yes. Single letter variables.
It's-
Yes, I love it.
It's frustrating, y'all. And this is like, I come from doing mostly Python, right? So I got these much longer variable names that have underscores and like very descriptive, and then we got W. It's like, all right. But what can you do? You can't beat them, join them, I guess, in this case. All right, let's go to the next little bit. What do we got? So we got JSON. We got templates. I'm trying to think of like what's the best way to represent templates. Is it template meme?
That's nice.
Got kind of meta there.
That's wonderful.
So templates. If you have done some, and I know sounds like some of you have, like PHP, Laravel, Python, Perl, Ruby. All when you do some of these frameworks, they have the ability to like on the server render a more complex response, where maybe like a whole HTML page, and they fill in the template because you take the dynamic data from perhaps the database or something, and you fill in the details, and you spit back the whole HTML chunk. That's what we're talking about with templates here. So let's take a look at this code. I did not handle this in a very nice way. So one takeaway from all this code is I wanted conciseness here so that you can see it all in one go. Don't write your apps like this. I mean, you can, like, do what you want, man, but I would not recommend this style. Like, put stuff in files. We're gonna see a little bit of how to do that in the future for doing templates. So I needed to have some kind of template that is represented here, and I chose to just do it inline directly into a big string. So how does this work? So we've got, again, we're gonna have a new route here that's get template. There's nothing magical about this name. I just wanted something clear, so it's just called template, just so that you had no ambiguity about what that was. And then we're gonna lean back on our movie, and I wanted to show a couple things. One thing is, like, this is coming from HTML template, first observation. There is a text template. When I was researching this talk, I'm like, what the heck's the difference? I don't know. The difference is that HTML template tries to make stuff safe for you. Again, like, you can really shoot yourself in the foot, or you can shoot your users in the foot, or maybe in the head. I don't know how you want to view that, but HTML template handles like details around security stuff. Tries to bake in some of that security concepts. Now, you still need to do your due diligence, and like, you don't just trust just because somebody else says they did some security stuff that yours is all good. That's not necessarily the case. But the reason that I have this this less than and greater than on this title is I wanted to show that this shows up on the response looking like a less than and greater than, and then when we can look at the actual HTTP data and see that it's actually been properly HTML escaped. And we didn't have to, like, up here we had to do this escape string stuff. And that's essentially what HTML template's kind of doing under the covers. If you pass in data, it's saying, I don't trust this data, let me do an HTML escape on it and make sure that it's web safe. Okay, so we've got our example movie here, Stick in the Shawshank Redemption. And then we build a template. And our first template, templates in the system, this is one of the features. I wasn't thrilled about what I saw with the template features here. They seem functional, but kind of clunky at the same time to me. But you give essentially a template a name. And then notice that, so what happens here is that we're going to parse this base content. And this is wrapped with a template.must, because the reason for that is if this fails to parse, like you messed up your syntax in your template here and Go's not going to figure it out, what the must says is if there's an error that comes back, I'm just going to like turn around and panic. So it's your way of saying like, don't make me deal with the error, just give me a convenient way to wrap this up so that I can trust that my template is going to be the right thing. So we parse the base string, and then notice I put a block in here, and it has a name. And that name matters when we get to the center template. So we've kind of got some symmetry between the block and then this other template string that's like, okay, I'm the answer to the block. So you can see how this is substitutionary, where this is where the content is going to go as these things kind of nest together. Does that make sense? Okay, so we got to parse both of them though, and then this is the weird part to me was we parse them both and we put them in the same variable. Like, it's not like a collection of templates, some container. It's like everything goes in the same temple thing, which is, I pulled from their docs name. I don't know why they chose temple as the variable name. Vowels aren't cool, I guess. Neither is T. And then, so then we get down to the final step where we take the writer that we've got from the response writer, and we take the input data, the movie, and we run execute. And so it's going to do its thing where it's combining the template data and the dynamic data, in this case movie, and it's going to fill them in. Now, as it's filling them in, where does that come from? So like there were things about this that are a little strange. Like this dot right here, block content, dot. Dot represents the thing that was passed in to the movie. Okay, so we're kind of passing the dot, the movie, into the next template, into the content template. And then here, in this content template, now you can trace it through, and okay, that dot, that was the movie, so now we can pull from the title attribute and the release here to get that data. So that was an adjustment for me. A lot of template languages I've worked with, this idea of the data that you would pass into the template is often called context. Go actually uses context for a totally different meaning, which makes that a little confusing. But context is, you could normally think of as like a dictionary or map, whatever term you like to use, of keys and values. And so rather than have just a dot, you would just say movie or something along those lines. So it's a little different in that regard, but otherwise it does the job there. Let's see this run, and then we'll do some questions on this. So we're going to run the app. We're going to go to, what I say was /template. Template. Okay, and there we've got our less than and greater than working. Actually, let's get rid of the dev tools. I don't think we need that. And if we do view the page source, that's tiny, but you can see, well, maybe you can't see. It's got the HTML escape characters here. So it's web safe. It shows up on the browser looking like a less than and greater than. But the template code has done the right thing and made it safe to display that untrusted data. because you could imagine that like somebody maybe provided this data, they're making a movie wiki or something like that, and they're trying to be sneaky. So that is templates, or that is a introductory view of templates. There's probably lots more you can go explore. I think the key elements for me is like if I'm thinking about, I make a lot of server rendered pages. That's what this is called, where you're doing all the work on the server. Can you nest stuff? That is vital. If you can't, then you would end up writing like a full HTML page every time in your templates, and you're like asking to repeat content. So the fact that it can have like a base and that represents the wrapper around stuff, and then you can start to fill in individual elements is very, very critical to making this a successful system at all. Still not the most robust one I've seen. Like I wouldn't know a lot of, so like talk about other features that you might see in other template systems. You might see the ability to like have other functions that you would call inside of a template to do different transforms on data. Sometimes it would be called filters or something like that, where I can't think of a good filter off the top of my head, but there's a lot of different ways that you can massage template data for better display purposes. Here's a good easy example. Like let's say you've got some kind of date time object, and it's represented in Unix seconds since 1969 or whatever that timestamp starts at, and you want to display it as like, well, how long ago was that from now? Is it 5 minutes from 5 minutes ago? So you can use a function or a filter to change that from the just raw seconds into a very friendly kind of display. So that's why you'd want that. But I don't know how you do filters, or if filters are even possible. You might have to do all that kind of processing outside of the template and then pass it in. But I could be wrong. Like there might be other features of the template system that need to be explored. Questions about templates? Cool.
Can you nest templates?
Yes. Yeah. So like we saw with the base
So-
and the content.
So I'm thinking of building a page. So I can put something here and something there, and each one of them is a template.
Yes. Yep. Yeah. How you structure that in the right way to get them all configured for each of your pages might be a little
Sure.
tricky. So there might benefit from some code to wrap that up and make that concise. But yes. Cool. So that's templates. Okay. Static files. There's actually in Python. There's a package called white noise, which does static files, and I feel like they have like the perfect tax name. Let's take a look. This was perhaps for me my favorite discovery like this process, just because I've seen a lot of different ways to do a lot of different code stuff over the years, and this was pretty slick. I hope you'll agree after you see it. Maybe you won't. Maybe you're a nerd, but okay. So what I didn't show in this directory, and let's back up. So here we are in this code repository, and I've created a static directory here, okay? And I've got a static file, which just says this is something that wouldn't change. That's the key element. So when you think of static files for a web server, you should think of like CSS files, JavaScript files, things that you just want to serve up, and then somebody would be making a request, and they're like, well, what is the page supposed to look like? And it goes and downloads a CSS file, and the browser does its magic and displays everything. So I didn't bother making a real CSS file. I just wanted a stand-in of like, here's a piece of static content. But that's the concept of what static files mean for web development. So here in our app, this is the coolest thing about this. There is a package called embed. Now earlier I said that Go will compile and ultimately make a binary. And this is an underrated feature probably for a lot of people, or you don't really realize the power until you've seen the other side of this coin. And the feature is this: you're done once you have that binary. Like that's your whole thing. You can put that on a machine. You can tell that machine to run, and it's glorious. In other universes, like Python, I love Python, but I'll knock on it a little bit. It's much harder to do that because you don't compile a thing, you have to ship a lot of files all at once, a bunch of them. And that could be all of your source code, all of your static files, all of a myriad of things. And those have to go together as units. So you have to find some way in your release process to bundle them all up, get your little bundle, and then put that thing on your server and run that whole thing. Now Go, because it's running a single binary, you don't have that problem. Unless you were going to have a set of static files to the side, and you're like gonna try and have your code open the file, read in the content, and then write that out. That is a way that you could do this. But embed is awesome in that you can skip that whole process. And what embed is doing, specifically this little magic line here, this Go embed thing, says take all of that content that you find at that relative directory, relative to this code, and put it in the binary. That is super powerful. And then expose that as a file system that then can be accessed. So you can, that content variable there, once this is like compiled into a binary, I think the method on it is called read file or something like that, which essentially gives you a file handle of this content that's been baked into the binary. This is so cool because then you don't have this problem where now I've got static files and this binary. I can still ship a single binary, and we can see this happen. So let's change this time. Let's go to do a Go build, and what that's going to leave behind is this executable right here, Go standard app. Okay, so we've got Go standard app. Let's go over to well, first of all, let's get the static file just so we know what we're looking for. So I've got a file that says this is something that wouldn't change. Now, we can go find this binary, and I'm going to open it up. I don't normally, I mean, I'm reading the matrix, so I see everything we're doing, but for all the rest of you suckers, like, good luck. No, so in here is the actual data. Like, the embedding process doesn't try to do some kind of compression or encoding. So the raw bytes are just like present in the binary, which is so cool. It's just like available there. And so it's got like, the content is present, and now it's just accessible. So I thought that was amazing.
Great tool for a reverse engineer.
Yeah, probably does. You can probably do a lot of cool stuff with that. So, all right, so that's the embed part. That's how you get the files into the binary. But we still need to be able to like turn around and tell the server, how do you serve these things, right? And again, this was very, very concise. Like it's a single line. Actually, let's get rid of that. You can't see what we're talking about. Single line. So we now have a /static path, and we say, hey, web server, I want you to have a file server, and here's a file system. Now I don't, there's some details here about like the file system thing that was up above. They need to be adapted to fit this file server API, but you guys will get the code later and you can just run that. And this is in the embed documentation. So you don't even have to think about if you like want to go review this later, they have this example. Because I actually did this, I was practicing all this stuff on my Extreme Weekly, and I did this like doing this manually where I did the read file and I did some fancy path stuff where you can do like glob stuff and read in a full path with slashes and everything. And then I found you can do it in one line. I was like, oh, that's nice. It's nice that somebody like simplified this down to like what's it going to be a very common pattern. All right, so let's take a look at this. Let's do a go run. Whoops, wrong one, not the build. Go run on the app. And at this point, we should be able to go, and because it's a file server, we can go to static, and it's a directory listing. I don't know if you want this. I don't know if there's a way to turn this off. Like some people's like, you know, like you can think of what's it called in Apache?
Index.
Yeah, but there's like some special file, something attributes or access.
Oh yeah, .html.
Yeah, that file. There are ways to like limit what can be seen, and you potentially open yourself up to some kind of attacks, or if you don't want people just like willy-nilly taking all your files. So I don't know if you can turn that off with the file system stuff with the standard library. Maybe you can. Like I just didn't look hard enough for that. But you can see now that we've got this full path static file, it just like serves up the static file. So you could serve up your CSS file, JavaScript files, image files, whatever. Yeah.
So when you click that hyperlink, can you show me in the code what was called? What enacted that, like to bring you here?
Yeah. So I mean, I can try. So we had, we've got. So this whole server is going to be listening on localhost on port 8000. We've got paths for all these handles here. And so the reason we got to this file server is because our path looked like /static/. That's how it started. So it routed to there. That was this first portion here, as you can see. And then from there, it did then it handed off to this file server thing.
Okay.
That's right here. And the file server knows about this, and this content is that name of that embedded thing that we saw up above. And so that's what's wiring it together. Is like, as soon as you get the initial path, I mean, we could have called this thing, in fact, let's change it. Let's call it, that might actually work. Because I did discover, I initially had like an HTTP strip prefix, like we saw above, it was removing static. And then it was like, the actual path to the file was /static/static, then static file is like double nested. So I think there was some significance to accessing this in this name. But you could like name your directory differently and then use a different path if you wanted to just call this like S or something like that. But conceptually that could be done. And then it would still hand off. So you're at that point, your browser URL, you'd say like localhost :8000/s/static file txt. Make sense? Okay. Okay. Any questions about static files or embedding?
I have an idea, not really a question.
An idea? No, let's hear it.
Yeah, like, what if you just embed like a SQLite file, like into the binary?
Yeah.
You totally could.
You can analyze this stuff. Yeah.
Cool.
For like read intensive app, and like
Yeah.
see it's like config or something that's
Yeah.
like
How does it,
super config.
sorry, how does it work if you write stuff to this? Does it unpack a file system like when you run it, or?
I think it's read only.
It's just
I think
read-only.
that's the
that-
constraint.
That is the simplest answer. Okay, that makes a
Right.
lot of sense.
Yeah.
Yeah, it's just, no, you can't. That's not.
I'm trying to
Not
modify the
how
binary
it
line.
operates.
No. Yeah.
Okay.
Yeah.
Also, look, there is not an easy way to turn this off. You have to add like middleware, or
Oh,
like,
no.
there's
Okay.
it's very complicated.
Interesting.
I had a quick question about how that embed works, because when you looked at the binary, the raw text was just in there. There's obviously a couple concerns, right? One, if someone saw my binary, they would see my files. When you
Right.
say my binary, maybe we're already kind of.
If you're serving it up on your file system,
Yeah,
maybe
we're already
like you
bad
intended to
shape
do
as
that.
it is,
Yeah.
right? But the other aspect is like, well, what if the file's kind of big? I wonder if there's ways to like add compression there and let it like deal with that. I guess the files could be.
I thought about that too. Like, why is it? Because that seemed like a pretty easy optimization.
Yeah.
But my guess is that where my brain went was like, okay, sure, we have CSS files, we've got JavaScript files. We can agree that those are plain, those are just text files that should absolutely be compressed.
Yeah.
There's nothing stopping you though from putting JPEG images and PNGs and all this other stuff.
Sure.
And binary files don't. I mean, you can try to compress them, but they are already in a format that is kind of optimized. That it's generally recommended don't try and compress binary files. So what I don't know is like, how would the file system figure out what is good to compress versus what is not good to compress? And maybe there's an answer, but
You should probably also introduce then opinions about because then you would need to unpack it and go a lot of files. Maybe it takes a long time to decompress. Now you're
exactly. Or does it do
now
that
you're
on the
making-
fly, or is it,
right? Now you're gonna make opinions about where's the trade-off? What do we decide to do? So they're just, I can understand they're just wash our hands on it.
some simplicity and just like, no, this is just going to be in there raw. It was still fun. It was like, I'm like, I wonder what this looks like in the binary. I'm like, oh, there it was. It was pretty cool. Okay. Let's see. So we got static files. Let's talk about middleware. You mentioned middleware. I put this was like, most of them we have jokes on here, but this onion image was intentional. There's no joke in this. The idea with middleware is, okay, we've seen our little handle functions, right? And they are expressly for do that one path. What happens though if you want to do things for all the paths? Like how do you make sure, let's say like you have a website that you want to be kind of password protected, you want user accounts, that sort of concept. How do you add authentication that matters to every path, okay? So middleware is a very common answer for this. So the idea that you're going to add some layer, like imagine that the middle section here is your handle function. You're like the core thing that needs to do the work. But you want to add some extra layers on the outside so that can process, have an opportunity at least to process before and process after that function. So you can imagine like a user request kind of coming through the side of the onion. That's where the analogy gets a little weird, but you can put multiple layers of middleware around stuff for different kinds of functions. And so we're going to do a little synthetic example that is exactly that, where we're going to pretend that we have authentication. I say pretend because it was not interesting to go actually get this stuff from the database and stuff. So we'll start from this and we'll go down the list. So let's start from, and these end up looking mostly just like functions themselves. They're functions that wrap functions. And you can see what happens is, there it is. So you're going to wrap a router or wrap a mux. And remember that that those things respond to handler. They will be a handler ultimately. So if you receive a handler as your input, as long as you call that handler, you can imagine that like it's the middleware's job to pass on, like hand the baton to the next layer in the onion. Man, I'm really mixing metaphors, it's getting brutal. But that's what's happening with this next attribute. That's the thing inside that little core. And so when it calls, I mentioned earlier that the handler had an interface and I couldn't remember what it was. Well, it's this, it's serve HTTP. So you call next.serve HTTP to hand off to the next layer in that middleware stack. So this is going to return something that is in of itself is also a handler. It's doing HTTP handle func. So that's where you can see how middleware can be chained together. You can have as many middlewares as you want. Now, saying that, remember, performance matters. So if you do something stupid with like layers of middleware and you've got 10,000 of them and most of them only need one, then rethink your choices. But a certain amount of middleware is appropriate. So this is an example where we're pretending to be an authentication middleware. And we are pretending, I put this in the comment here, where we're going to look up some kind of information that came in with a request. Maybe a cookie is a very common way to do this. Like this concept is called session authentication. It's a super common pattern. You will find this in virtually every big web framework out there. So it's going to look up this attribute that's been encoded in such a way that it can't be tampered with, and it would then take from that attribute and pull out the ID, check against the database and do some stuff, and eventually find out, oh, you're user 42. That's your user ID. And so we're going to stuff that into the request, essentially. And we're going to take advantage. I mentioned earlier there's this context concept in Go. Context is normally used for handling like timeouts. If you can set like deadlines of like how long is this thing supposed to take, and if it takes too long, like interrupt it and stop it. That's what context is often meant for. But it is also a place that can conveniently take an extra value. And you don't want to stuff a lot of values into the context, but sometimes middleware is the best place to do it. So what we're saying is here, we're saying make a new context. That's what CTX here is. That's the convention name the whole Go community centralizes on. Take the previous context from the request. Remember, R is the request. And then add this key and this value. So 42, this is the piece that should be dynamic if we were doing this properly. But the key is like this constant. This is a thing that other code later on is going to know. Look up this particular key in this context. We'll see that in just a minute with the admin middleware. And that's how you check this stuff. So this is how you can connect two disparate pieces of middleware that might need to be functionally related. So the notion here is somebody logs in, they have this session, and with every request that comes in, we know that it's them. And then we pass that along to lower layers in this chain so that they can react to that. So to wire that up, all we had to do, here coming back to our server, is wrap the router in this middleware. So now we have one layer of router middleware that's there. Does that make sense so far? You'll see that concept? Okay. So let's tie it to the other half. This is kind of like a 1-2 punch in this scenario. So we've got our auth middleware, and then we want to pretend that we have like an admin section to our page. So you are the admin, and you know, your ID is 42 because that's the right ID. And if you don't have that ID, you're not going to get access. We're not going to permit you in. So here's the other side of this equation that is checking. It's pulling out the value from the context. It has to do a cast here so that the context doesn't like keep track of type stuff. This is a typed language. That doesn't mean anything to you. Don't worry about it. But you get the string ID out the other side, that 42 from earlier. And we're checking and saying like, if you're not 42, you're not an admin. So get the hell out of here. And then we're calling the next thing. So if you are, we're going to proceed and pass you on to the next thing in the chain. Okay. So that is the admin middleware. Now to use that, we've got a section down here where we've got a new MUX, new router. And we've added our dashboard, our admin dashboard. And then we hook up the admin dashboard to the /admin of the site. But importantly, we wrap that router in that admin middleware. Nothing else, all these other ones will still continue to respond and they'll just do their thing. And yes, they will go through the auth middleware. And so there's that call, so that value will be set, but they're not going to do anything with it. So just be like, all right, go ahead, give me your value. Okay, so now if we run this, so I'm going to first show you, so the server started. We can refresh this page. I just refreshed. And you can see that it went through the auth middleware. But it didn't do the admin middleware. Makes sense. We didn't call the admin. No code path should be hit there. But if we switch this now and we go to our admin section, so admin dashboard, if I could type. Dashboard, yeah. So it's a secret to everybody. So I could recompile this program and change the admin ID so you'd see the failure and show you a 501 or whatever the HTTP status code for forbidden is. I think that's
403.
403. Yeah.
Oh yes, not a 500. Yes, thank you. So that would show up on there, but this is the basic concept. So we got through, and in fact, I did log a little bit. So this is our second request where it went through the auth middleware again, and then immediately after that went through the admin middleware, which it could only get through if it made it through that guard that was checking for the ID. So that's middleware. Middleware is a super powerful concept that it's used for a myriad of persons. Like off the top of my head, you could think of, like I looked at this with Django. Django has the same concept. They structure a little bit differently, but security middleware, like you wrap the whole thing in a security check that, maybe your server is configured to use TLS. You expect all your requests to come in on HTTPS, but somebody tries to request HTTP, an insecure connection. So TLS middleware can, a security middleware can look at the request, see what protocol are you coming in on, and be like, hey, that's not secure, and then do a redirect to the same path, but with the security, the actual protocol enabled, so that it forces that connection to go through on a secure channel. So that's just an example of a kind of middleware that you could do aside from authentication. If you're like, what else would you use this for? There's a ton of other cool things you could do with middleware. Any questions on middleware?
I'm curious. I have to look into this. Like with Go, right? So the way you added middleware is that you did a function call. You called your middleware as a function and passed it a thing, and that returned a thing that implemented the same interface, and so it still worked. And so in my mind, it's like if I want to stack middleware, I've got this weird kind of functional programming thing I've got to do, or I've got to like reduce kind of thing. I don't know. You're starting to get into
So
like
some people will make like a chain function that will then accept it in a list, and it will wrap that all for you, so you don't have to. Because if you could get like it could get pretty nested in.
I could just see how you have like a couple of like again like a couple of always there ones that you just.
Yep.
Whatever app you're building, you're going to want that, especially if you're doing like microservices stuff where every app's going to have the same kind of boilerplate or something.
For sure.
Logging, whatever, request IDs, whatever kind of stuff like that you want to do.
Yeah, tracing. Those are
Yeah,
stuff.
for certain.
Mm-hmm. Cool. All right. That was yes. Somebody have a question? Oh, I'm just hearing things. So we got middleware. Okay. Database. So I called this talk No Frills, Just Go. This is the one area where I reached outside of the standard library, cheated. And I not for lack of trying. I really looked to see if there's any way to do this. So what Go does include in the standard library is like a database driver interface. It's basically the interface that they expect any database that wants to connect to Go to use. But they do not ship with a particular database of any kind. This is actually different from some language. Python includes, you can go right now, go import SQLite 3. Boom, SQLite's available to you. So you could do stuff with the standard library using an awesome database. SQLite's an amazing database. So unfortunately, that wasn't possible. So for this last check that we're going to look at, I think it's the last one. We do bring in one driver. So if I go over to the Go mod file, I looked at what were popular drivers, and this seems to be one of them. This Mat and Go SQLite 3, it seems to be one of the ones they recommend, and has tons of popularity on GitHub. So the one time I reached outside of this, and if you wanted to do this yourself, if you were following along, you can do go get, and then you give it the path to import, and it'll bring that into your module file. And then the next time you build it, it'll say oh, you apparently said you needed this, so we're going to compile this with this available. Okay, so that's that. Looking at the actual app code for this, we've got a couple of new things here. So we've got this database SQL, that's our interface that we're going to use. And importantly, we have to bring in this SQLite 3 import. But Go is it's kind of weird about, well, it's not weird, it's just a choice. Where if you have unused variables or unused anything, it says nope, not allowed. I'm not going to compile until you clean up after yourself. Which is most languages don't do this. Some people view it as extreme. But you can effectively say, I know I'm not caring about this variable. I know I'm not caring about this import by giving it this underscore name. So we have to bring in this import and then use an underscore in front of it to say, I really want this to be here. You may not like it, Go, but I'm telling you, why I want it. And this was important for, well, actually, let's just try it without it, just see so you can see. No, it's not going to make sense if I don't show you first. Let's get to the next layer of this. So we're going to use SQLite 3, which is a file. I cannot, I've been studying SQLite 3 lately. It is so cool. You can go so far with a freaking file. It's amazing.
It's like a single header file too.
It's awesome.
It's crazy. It's awesome.
So here's our example. Now, yeah, I'm taking it to the next level here. So, because I didn't want to deal with having to recreate tables and stuff each time. So what we're doing here is we're opening a SQL database. We're using this driver API, and we're saying we want to use the SQLite 3 database engine effectively. Typically, this other attribute at the end is the path to your file that your database engine is where does the database live? You got to tell me. This specific syntax, this : memory : is actually unique to SQLite 3, which tells SQLite 3 the file's not going to be anywhere. Just bring it in memory. Okay, so when we stop our process, the database goes away. So it's not is not a great, unless you just want like a cache kind of thing, this is not a great pattern to follow. Like if you actually care about persisting your data, maybe don't do this. Because your server will crash at some point and then you'll lose all your data. But the reason I did in-memory, like I was saying, is because I want to do this I wanted to show like this is how you would create a table. You used to like execute some DDL, data definition language, and run. So I created a DB instance on line 58 here. And then we can actually start interacting with that. We can say execute, and then we give it the particular SQL instruction that we want to execute. So we've got this DDL statement to actually create a table. This is the syntax that's specific to SQLite 3. This will vary a little bit depending on which database you choose to use. And then we inserted Alice into this, classically Alice and Bob from like security stuff. So now that you've seen that, let's actually go back to the top here to the import section, and I'll show you what happens if we don't have that import there. So if we run this, it should blow up in our face. Yep. So it says, hey, I don't know what SQLite 3 is because it didn't have the driver like imported. It didn't like know about it. So I guess the fact that the driver is imported must trigger like a registration with the SQLite stuff or SQL stuff. Yes.
Okay, so I think I know what you're saying. You're saying that you import that library, but you're saying, hey, you're gonna underscore say. Oh, that was me. That's my phone. You're saying that I'm putting this underscore there to say import it. I'm not going to use it in this code, but import it because it sort of registers itself with the database system inside of Go. So like that's some under the hood sort of registration that we don't see, but it's there. And then when you don't do it, that's what happens.
Exactly.
Okay.
Exactly. So that
I see.
Because I was wondering the same thing. It's like, isn't just having this in my Go module, like it's not just going to be enough to know that it's like magically registered? No, is the answer apparently.
It's a little not idiomatic to go to for some reason.
It does. It felt a little weird. You're right.
This is a little magic-y, and that's like very Python and not really Go.
So we add this import, and now we should be able to run it. And so it is going to create that in-memory database. It creates, like, it's just sitting here right now. But it created that table. It inserted the one row into the database. So let's go back to the rest of the file. Let's leave that running for a minute and return to this. So here's our thing where we create the database. We're using a keyword that's available from Go called defer. So when the program ends, at the end of it, anything that was deferred will like execute at that time. So essentially, all of this code underneath is going to run. And the reason you want to do that is like you could like instead at the bottom, at the very end, have like db close kind of thing. But the nice part about defer is that it keeps the opening and the closing together. This is especially important if you like have things that you must close. Like imagine if you didn't close your database file and it just like the process ends and something didn't flush and you crap, we lost data and data integrity issues. So having the symmetry near each other, open and close operations, is a very common thing you'll see. So that's the power of defer. But that's all that's doing. It's like just delaying when it's going to run as like a built-in language concept. Okay, so whoops, let's keep that back. So we've got our database created, and then we've got one final handler in here that is database. Again, this is just for demonstration purposes. Do not write raw SQL in a freaking handler function right in your main file. That's just bonkers stupid. And then like log fatal if a query fails. You're just asking for trouble if you did that. But it was to show that hey, we can take our database, we can take a query, we've now got it from the table, and then we can take the writer and write this stuff out, and that's all available and working. So final thing that we should be able to show is DB should show the ID is Alice, and there's Alice's age. So I felt it important to include the database aspect because it felt like the one factor that really limited greatly the utility of the standard. Like I could make a ton of stuff with all that stuff I showed you, and you could do virtually everything that most web apps will want to do. But then if you couldn't actually store data, you could store data, but you'd be limited to like writing to files, which is going to be slow, or keeping some in-memory thing, which is maybe fine for your purposes, but also not super. Or delegating, like another pattern I thought of showing but I just opted not to, would be like calling a different, like having an HTTP client inside your handler that is calling some other service to write, do API calls there. So all of those things you could do without SQL. It's all good.
D&D is on, I don't know why.
But I just found that, like I want to be able to store some data. So it felt like it was appropriate to show you all how to do that. And if you want other tools, this is all like you can expand from there. You don't have to use raw database access. There's object relational mappers. There's tons of different patterns out there for accessing data. So I think that was everything. Yeah. So ultimately it's just Go mostly by the end. But thank you all for your attention. It's good dialogue. Appreciate you being here and chatting about it. Yeah.
In the universe of tools that I can build a website with,
Mm-hmm.
is there a simple why I would want to learn another one?
Good question.
Or,
Yeah.
where is this? Where is it going? What is the future of it? Is that a simple answer?
I don't think it's a simple answer. I'm happy to try and entertain it a little bit, though. It's a good question. Yeah, there's also like the question, the choices you'd make on what kind of website you want to build are extremely context dependent, of course. But I think for me, it's like part of this is educational. Just knowing other ways that things can happen make me a better developer. If I understand how Go does it, I understand how Python does it, I understand how Perl does it, and I think that just rounds you out as a person who understands technology, which will equip you better.
I completely understand that.
Yeah.
But when I go to the client
Oh yes.
and explain to them that I'm going to use Go to build your new website, and the last website that I worked on in a big way is essentially a regional telecommunications. They deliver the internet to my house or to my office,
Okay.
and I have to go there and register myself, order the product, pay my bills,
Yeah.
and do all those kind of things. And my guess is I'm not going to use Go to do that.
Yeah. To that, I'd say like if you already have, so if you are trying to charge people money to make a website.
Something people do occasionally.
Yeah, exactly.
Right.
I think my advice would be like, use what you know that's going to get them, because they want like, solve my problem. They don't give a crap that you're using Go versus PHP versus Java, right? Like that doesn't matter to them.
It's what's it going to cost? How long is it going to
Exactly.
take?
And those are the right questions. Those are questions they should be asking.
And is it going to be secure?
Yep.
And is it going to actually work?
Yeah. So I think where I'd go with that is like, if you are getting in development, and there are plenty of companies that do use, my company uses Go. I use Go every day for my work. That's what we do. It's not all standard library stuff. We've brought in a whole ecosystem of packages and things to use, so it's different, but it's still Go. So it's like, I will at some point I've built up enough experience where if I want to start my own business, I feel like I have a competency where I could do that and be successful with Go.
The fact that your company is using it on a daily basis means you've got a whole library of tools.
Right.
And things that can be reused.
Yeah. But to that though, I mean, there was a point where our company did not use Go. So somebody in the company made a decision saying, we were on this, and we're now going to switch to this. So that's an interesting like intersection of, it's not like a directly serving a customer, it's not like an academic thing. It's like somebody made a business choice to pick this. Yeah, their reason, their rationale was about performance. They were they were heavy. This is actually I was from two companies that merged. This was pre-merger. I was from a company that did all Python. My teammates who were in the other legacy company had a big Ruby on Rails application, and they were having performance issues with that application, and found that Go is known to be quite fast. It's not the fastest library out there, but there's a balance. It reaches a nice medium point between like complexity of writing stuff and speed. So that they opted to say like, this is what we're going to do. We're going to invest in this, and they started with something small and like slowly built up over time. And now today, we are actually phasing out our other languages, our legacy languages, and we will ultimately be almost exclusively a Go company. So that's the kind of journey that, as a big corporation, is just one example of something we did to actually migrate to Go.
Can you give me an idea of kind of the range in terms of size using whatever metric you want to use for size?
Like how much code?
How much code? How big? I'm
So
trying to get at how big is the project?
sure. Yeah. Oh, okay. So I work for a corporation that we have thousands of Dockers that work for us. We have an engineering team of hundreds of engineers. So it is a system that has probably 300 different services that are kind of all talking to each other, doing different things. So this was a unifying technology that was trying to like replace lots of the little pieces, those microservices.
So you can legitimately say that you're using it for business class solutions.
Absolutely.
And you're confident in using it.
Oh, totally. Yeah. I mean, the Go itself, they have this silly mascot here, but it originated from Google, is the company that began the language.
I've heard of it.
I have no lack of trust in their ability to for Go to do like business critical workloads and that kind of thing.
Yeah. So from one perspective, companies like Google and others have the new toy of the year sometimes, and there's always the question: do you invest your company's resources?
Yeah, that's a great question.
In this shiny new toy.
Yeah, I think before we were talking about before we started the recording.
Yeah, I got in late.
That's all good. We were talking about Laravel. Laravel is a big, popular PHP framework, and I think it's one of these tools that it is a very full framework. It does a lot of things for you, and there's a lot of companies that have a long legacy. I mean, PHP powers probably 75% of the internet, so it's a pretty natural choice for somebody in that kind of company to say like, we want to stick with PHP. This is the language because there's like also human aspects to this, right? Like if we have developers who know this language, why should we pick this new language? There's risk involved with that. So they might have a different migration path where they stay in the same language but pick a different tool set that's like better for their PHP developers.
Well, is there a cadre of, I advertise, I want an expert Go developer?
That I don't know. I mean, I'm guessing there's somewhere, but I'm not aware of resources off the top of my head. Yeah.
Thanks.
Yeah, no problem. Any other questions? Cool. I'll stop on the recording.
Yes. Down. You answered one of them already, but like references for learning on Go, is there anything that you do? Is it just, I know you guys are awesome, I have a very big fan for software engineers, developers, programmers, like that. You guys blow my mind. But if I wanted to go somewhere to, gain knowledge on Go, maybe get my hands dirty, something like that, where would I go?
Tour of Go, right? The tour, a little tutorial for
Yeah,
Tour of Go.
there's a couple of places. Tour of Go, like tour.
Like Tour de France?
Yeah. That's one place. And the other one that comes to mind now. This is a little bit of a challenge because I've been programming for a long time. So it's like, is it appropriate because I've seen some stuff and but I'll suggest it anyway. And let's actually go to it. So there's a website called Exorcism, exorcism.org, and this is a pretty cool learning website, you can see I've done this is actually where, so I didn't know Go professionally until a couple of years ago. So I use this to like bootstrap my own knowledge. Now, what I don't know, the part I can't speak to is like, I was able to lean on all of my previous
That's
programming
true.
knowledge
Absolutely.
to know if it was
Absolutely.
right or
That
not.
makes sense.
But I will say that, wow, this is so laggy because of the display, not because of this website. So there's like a lot of languages that you could learn from on here. And many of them will say somewhere, see how it says this like learning mode here?
Mm-hmm.
So there is like a skill tree that
Yeah.
kind of goes along. So it starts you from like assuming you don't have much knowledge about programming, which
Yeah.
that's kind of your
Yeah.
universe. And actually, if I go to this Go one here, and we go to the Learn tab, you can see the skill tree. And so, okay, this may not be enough here. So each of these things, each of those check boxes, is an actual like programming assignment.
Yeah.
Okay. What's cool about this that I think is maybe more powerful than just following tutorials is that all of these assignments, they come with some automated tests that will check your code. So not only do you like write the code and see if you got it right or not, but you can have something that you can run and that tells you, did I get it right? Did I get it wrong? And so that's pretty powerful along the way. If you wanted to, they even have like mentorship stuff here. So if you're wanting to support and pay for, like there are
Yeah.
people that mentor on here. I've not used those particular features. I've just been more of like, let me explore it. But it's got this whole skill tree that you can follow down and do a bunch of different exercises. And oops, there's a new one. Apparently, I did the whole skill tree at one point, so they're continuously updating these things. And then, like, if you really want to go nuts with this, like, I did a lot of these exercises. There are tons of these that I did not do.
Wow.
And they give their rating on what's the difficulty of this problem. So some of them are really hard. Some of them, guys, I don't know. Like that one's hard. So, so they kind of score them. So the criticism I have of exorcism sometimes is that I think that it does, like I'm teaching my son and my daughter Python. We homeschool, and like my son's 12, we're teaching him. And I found, at least on the Python track, that the explanations get like a little bit too academic too quickly. And it's like, I'm able to bring them back. It's like, oh, I'm a programmer. You don't need to know that right now. That's a waste of your time. Let's give you the important, relevant details, and let's just skip all this stuff. And that's where, unless you had some programming buddy like to help keep you accountable and like keep you on the right track, you're not going to know, and you might end up finding yourself like researching something you didn't need to know. But if you're dedicated, like you could read it and like it could dramatically accelerate your learning. So
But yeah, if they were like, oh, this is like a thing that takes like an iterable object, and here's what an iterable object is, and here's an interface for it, and you're like, oh, like you give it an array.
I just wanted to go in a loop.
Give
like,
it a list. Just give it a list of things.
Yeah. So yeah,
That's
exactly.
a perfectly
That's-
fine iterable thing.
That's a good example. And so there's a bunch of tools that come with this where you can like download the exercise and you can work on it locally, which I would definitely, if you did do that path, I'd recommend making sure like there's an online editor. So you can do all of this stuff on the website if you wanted to and program in the website. It's kind of cool, like if you really are limited in what your access is. But part of the challenge of being a developer is also setting up your tools. And if you go through the process, and they walk you through a lot of this, if you set up your tools, you position yourselves to be more successful in the future as well. Because like you're growing your knowledge in a context that is like your normal environment, rather than learning through a web API. So exorcism's pretty great. Give it a shot.
Appreciate it. Thank you.
Yeah. Yes.
I have a similar question, but kind of like, I feel like as I've like learned a bunch of these programming languages, dabbled with some of these frameworks, I feel like a lot of this stuff they abstract away. So I'm in a situation where I have a bunch of knowledge gaps, like,
Mhm.
right? But what I've noticed is that there's a ton of patterns, right, between these patterns and like fundamental concepts, regardless of like the language you use. So I was wondering, as like a junior developer, someone trying to learn, what are some of these concepts and patterns that we should really nail down? So for example, like today I asked you about like HTTP request writer. I didn't know that was like a thing, to be honest. I like understood how HTTP requests work. There's a header, there's a body. I've worked with some of that stuff before, but I didn't know about that. Another thing was, but I feel like that's kind of like now looking back, I feel like it's kind of normal to have something like that, right? Another thing you mentioned was like buffers and streams, and I was like, I hate working with those. I don't understand those all the way.
Sure.
So what were some of these like topics that like regardless of language, and like we did talk about binary today, which made sense to me as well. What are some of these concepts that you like need to know? Because like these languages, like I felt like with JavaScript, I was like so annoyed because it was just like these libraries just change like every single day. Like it's so annoying. Like I came back to Next.js after a year, and like there's a new router system, and I'm just like this completely deprecates all of my code. You know, like or you know.
Well, we can rag on JavaScript's notorious for that, so I won't give them too much grief. But like I think that community is so fast and that they're like willing to change paradigms a little too freely, in my opinion, and it ends up like biting developers like yourself. Like, I just learned this thing and now this is not the way to do it anymore. What the heck? Like, so you want, my opinion is you want something a little bit more stable than that, some concepts that are a little bit more base. I'm trying to think of like, where does one learn about like these base concepts? Okay, challenge mode. This is an amazing book. You can read it for free. You would learn an unbelievable amount of stuff from reading this book. What is this book? This book is like, how does a language like Python work? How does a language like Ruby work? They're considered interpreters. What does that mean? This guy, this is Bob Nystrom, is a great teacher. This content, like I bought the actual like print version of this book. All right, let's just jump in for a minute here. He's got the whole book. He's meticulous too. It's like perfectly typeset. Like he's a stickler for details. He's got a style that I think is really friendly, where he will walk you through like computing history, the core concepts. He's got humor kind of baked in. Like I cannot give enough praise for this book. If you're truly trying to learn the base kind of concepts that you're talking about, like you would be well served by learning a lot of stuff. And what's cool about this is he walks you through, he makes up this language. All right, so framing. This language he's got is called LOX, L-O-X. And he gives us kind of the grammar, the syntactic details of like how this language works. And he's like, this is what we're gonna build. And then he does two different implementations of this same language using a base language underneath. First version is using Java, and the next version is using C. You don't know Java or C, it's okay. Like he's got like every little bit of code along the way kind of walks you through it. So it's really well done in that way. And just along that journey of building up a language step by step, you're just going to get exposed to the different concepts about buffers and memory and files and like all of these different things that matter. And it builds a foundation that I think is super valuable. That's if you like want to understand language. There is another book, if you're more like into the how do computers work thing, if like that's where your brain goes. Like some people, my undergrad was in computer engineering, and that was from from the physics of how do transistors work, all the way up to like I see bits on the screen, and I learned that whole stack. It took me 4 years to do it. But there's a good book. It's called Code. I'm drawing a blank on the author's name. Maybe I can go find the author after I stop the recording. but it explains like how do computers work from the base of like what was the journey of computing, and walks you through the history to build up that knowledge that way. Also an excellent book. So sort of depends on like different vectors you want to go. Like, clearly I like reading, so if reading is not your style, maybe that wouldn't work for you, but those are good resources.
Got you. Thank you.
Yeah.
No, I've just been like I'm familiar with Java. I learned it in high school and whatnot. Honestly, I had a really good teacher. She worked at NASA.
Oh, cool.
But like she retired and whatnot. So I learned a lot of that stuff, and then I was like, as I've been like doing like different projects, different side projects, like even when I set up a Unraid server recently, and I just learned a lot of like networking fundamentals which relate to, web development, right?
Mm-hmm.
And I've kind of doing it myself is like brings a different level of understanding
Totally.
than just reading about it.
Yeah.
Although or rather I would say I read about it and then I felt like I really connected everything together with doing it myself.
Yeah, and that's part of why I really like this book, is that like it's not show. This is the kind of introductory chapter, but once you get beyond, once you actually get into the code, he like every little example you actually get your editor going, like encourages you to follow along, and for me that was a really great way to learn. I mean, I also learned just by reading, but having that hands-on stuff was pretty slick.
Thank you.
Yeah.
Just because I've gotten tired of like just learning syntax from like all these languages, I'm like, all right, like it's the same thing, like just differently, like looks different. It's like
And this one is pretty lengthy. This is quite a commitment. There's a shorter one. It's about it's the same kind of concept, making a programming language, but it uses Go as the base language. So if you're interested in Go, you might want to do that. I can dig up the name of that one. The name is slipping my mind at the moment, but I'll find it. Yeah. Any other questions? Awesome. Thank you all for coming tonight.
Thank you.
Thank you.
Yeah, this is great.